Once when the complete phase of system analysis and system design completes, the next phase of the waterfall model begins. The iterative model is very, very important, which helps us to come up with new information. Here in the fourth phase, you can plan what shall be incorporated in the next iteration. So both verification and validation is carried out simultaneously. Hello everyone, it is Dr. Ravi Kumar YB. Today we shall see about the software development lifecycle, which requires the software paradigms like as to how we can find out the ways in which the principles of software engineering can be incorporated into the software development process. That is, in this case of software development lifecycle, we have different types of models. That is, the waterfall model at the very beginning we have, and then we have an iterative model, and as a second model. In the third model, we have a spiral model, and as a fourth model we have V model, and as a fifth model we have Big Bang model. All these are different types of software development process in which you will come across different ways of designing the product, that is the software product. That is, if I consider the software product that is waterfall model. The waterfall model is a model that relies completely on the previous phases of that. That is, if you consider the iterative model that considers each and every phases of this software development is considered in every iteration. So thereby you will observe some kind of differences in every model which you will come across during the process of software development. If that is the case, let me take you into the details of software development process in which you will come across the software development life cycle. Life cycle indicates that at the beginning, which is the first phase of a software development process and which is the last phase of a software development process, right from first phase to the last phase, which are the different phases which you will come across during the process of software development. That is very, very important here. That is, if you consider the software development life cycle, that includes the very first model, that is the waterfall model. Let me take you into the details of the pictorial representation of waterfall model, wherein you will observe that the very first phase of this waterfall model includes the requirements gathering. What is the meaning of requirements gathering? The name suggests that, suppose if the developer wants to collect any information as per the requirements of a client, then he has to gather certain information from the client or from the customer who wants to have a software as per his requirements and needs. Then it has to be collected. That is called as the first phase of this software development life cycle. In this, you are observing that there is a graph which is moving downwards that indicates that after every phase, the next phase begins. After the completion of every phase, the next phase begins. In this case, after the completion of requirements gathering, the system analysis begins. System analysis also includes the designing the system. The designing of system is represented in the form of a pictorial representation. That is, what is required for a client is going to be designed in the form of a pictorial representation. That is, both analysis and design is carried out in the second phase of this waterfall model. Then, if you look at this, the third phase, that is coding part, which is very, very important here, that is the implementation of this software product is carried out in the form of the technology which we have or the technology in which we are aware of. That is, the coding is carried out in the third phase of this software development life cycle of waterfall model. If you look at this, once the requirements gathering is completed, only then the system analysis begins. Once when the complete phase of system analysis and system design completes, the next phase of the waterfall model begins. That means the coding begins. Once when the complete implementation is completed, that is the development of software in terms of coding using any of the technologies like Python or C#.NET or any of the technologies, once when the complete software development process is completed in the phase of coding, we will move on to the next phase, that is testing phase. So if you look at this, there is a link from one phase to the next phase. Once when the coding phase is completed, we will move on to the next phase, that is testing. In case of testing, we will test the number of test cases for all the possible set of input combinations. That is, for any given input values, we will check whether the requirements of a client is going to be met in that coding part. That is called as a testing, which is the fourth phase of this software development life cycle. That is, if you come across the fifth phase, that is the implementations, you will consider the implementation or the integration of all these modules into one single module, and you are going to deliver it to the client, wherein you will see that whether the implementation of the work which is carried out is working properly. That is, moving on to the next phase here. From here to here, you will observe that the operations and maintenance. Once it is delivered to the customer, we will go to the customer's place and we check whether software product is working according to the requirements in the place of clients. That is called as whether the operational and maintenance. In the previous sessions, I have mentioned that is transitional is one of the important good characteristics of a software development life cycle. The second one is operational, and the third good characteristic is maintenance. So among all these things, we have the operations and maintenance as well. So we are going to check all these things. So looking into this, we shall see that this is a simplest model of all the type of different types of software development lifecycle model, but there is a drawback with this waterfall model. Let me tell you what is the drawback of this waterfall model. In case of this waterfall model, you will observe that once when the complete phase of requirements gathering is completed, we will move on to the next phase, that is system analysis. Until the completion of this requirements gathering, we cannot move forward. We cannot move forward, that is to the system analysis phase. Suppose if there is any flaws we identify in the first phase, we cannot move forward until the flaws are resolved. That is, the resolution of flaws is to be identified and completed successfully in the same phase. Then only we shall move on to the next phase, that is to the system analysis phase. In this case, once when the system analysis and design is completed, we will move on to the next phase, that is coding. But there is a drawback, that is you cannot come back to the previous stage, that is to this requirements gathering. You cannot come back to the previous stage once you proceed further. That is the main drawback of this waterfall model. In case of this waterfall model, you cannot undo or you cannot redo the changes which you have already incorporated into the software product during the process of development of a software product. So that is the main disadvantage or drawback you are going to identify in case of waterfall model. So similarly, that is, you will observe that all the phases of the SDLC will function one after the other in a linear manner. Once when the first phase of a waterfall model is completed, we will move to the second phase, that is to this phase. Once when the second phase is completed, we will move to the third phase. Once when the third phase is completed, we will move to the fourth phase. So on like that. So if that is the case, we will consider it as a linear manner of progressing towards the next and subsequent phases. In case of waterfall model. Similarly, when the first phase is finished, only the second phase will start and so on. Next, this model assumes that everything is carried out and taken place perfectly as planned in the previous stage. What is the meaning of that? As I have already told you, once when the process of the first phase is completed, we will move on to the second phase, that is to the system analysis and design. Once when the requirements gathering is completed successfully according to the planning, that is according to the requirements of a client, if every requirement of a client is collected, then we shall go to the system analysis and design. But it is very difficult at the later part of time when the client comes back and approaches for the new changes into the existing system. Then it is very difficult to go back and do the changes. That is the main drawback. Again, practical difficulties you will come across when you start developing a software product with the help of a waterfall model. And there is no need to think about the past issues that may arise in the next phase. That is what? If you observe any flaws or mistakes that you have committed in the requirements gathering phase, that has to be resolved in the same phase itself. If you progress forward to the system analysis phase, having the flaws, then you cannot come back and do the changes in the requirements gathering phase. That is very, very important thing you need to understand here. You cannot think about the past phase of a software development. You can think about only the future phase of software development. Then it does not work smoothly because this model is not at all dependent on the next subsequent phases. It depends completely on the previous phases. That is, what is the changes that you have incorporated and completed successfully in the previous phase is going to be carried out and successfully incorporated in the next and subsequent phases. If you have any flaws identified in the previous phase or in the present phase, that has to be incorporated in the same phase itself. If you move forward having the flaws, then you cannot come back to the present phase or to the previous phase to resolve the issues. This sequential nature of model does not allow us to go back and undo or redo our actions. The same thing. We cannot incorporate any changes once we go ahead, and we cannot come back and do the changes. Then this model is best suited when developers are already aware of it. That is, when the developers are aware of the similar type of software. If they have already developed the similar software in the earlier phases, then they can go ahead and make use of this waterfall model because they are aware of it. They are having the capability to complete the software development of a product that is essentially required when they have already completed the similar software product. Then it is okay. Otherwise, it is very difficult to adopt the conventional waterfall model. Then you will come across the second type of model, that is iterative model. What is the meaning of iterative model? Let me tell you that. An iterative model is the name that suggests that a statement, if I consider a logic in a program, that is, suppose if there are 5 statements in one single for loop, then all these 5 statements must be executed sequentially, one after the other in first iteration. Then in the second iteration, again, all 5 statements must be executed sequentially. Similarly, in the third iteration, all these 5 statements must be executed sequentially. So what is that happening there? All the phases, that is, whether the requirements gathering, system analysis and design, coding, testing, implementation, operational and maintenance, everything must be carried out in one single iteration. Then what is the use of this iterative model? And of course, it is very much useful. How it is going to be useful? That is the concept of discussion in case of iterative model. Suppose if there is any new feature is to be added, then you can do it easily in the next iteration. That is, in case of n-1th iteration, you have already completed the requirements gathering, system analysis and design, then coding, testing, implementation, operations and maintenance, everything is carried out in the n-1th iteration. And if you go ahead in the second iteration, that is in the iteration n, where n is equal to 2, that is in the iteration 2, again you have to follow the same procedure. You have to come across the requirements gathering, system analysis and design, then coding, testing, implementation, then operations and maintenance, everything has to be carried out in the next iteration. So again in this iteration, the new features are required. Suppose if there is any new feature is to be incorporated, then obviously you can do it without any mistakes or without any problems. So this is one of the advantages of iterative model in comparison with the waterfall model. So if that is the case, you can see that the iterative model is best suitable for many of the applications. For example, Jelly Bean is a version of operating system released earlier. After that, so many different versions of Android operating system has come to the market. Right? Now, when the operating system is released to the market and incorporated into the mobile phones, it remains operational in the customer's mobile phone. Suppose if there is any changes incorporated into it in the operating system, suppose if there is any enhancement or the new functionality incorporated into the existing operating system, you can do so and release it as a new version of operating system, and the operating system shall be incorporated as a new feature in the customer's mobile phone. That is, the new version of operating system shall be incorporated and updated in the mobile phones. Because the new changes, the new information which you have come across, the new planning which has come to your mind shall be incorporated and released into the market as a new version of this software. So the iterative model is very, very important, which helps us to come up with new information which shall be incorporated into the software product. So it is very, very important and essential for every software development process. So the same thing is explained here. This model leads to the software development process in iterations. That is, in iteration 1, you will come across all these phases. It projects the process of development in cyclic manner, repeating every step after every cycle of SDLC process. That is, whether it is a requirements gathering, system analysis and design, third one, coding, fourth one, testing, fifth one, implementation, sixth one, operational and maintenance, so you will come across all these 6 phases in the first iteration and all these 6 phases in second iteration So there is no need to worry about going back to the previous phase in the next iteration. So which is very advantageous. So that is the same thing is explained here. The software is first developed on a very small scale. That is, with few requirements of a client, we are going to implement the software project. Later, if he comes across any requirements, let him come, we shall do it in the next iteration. That is the plan we have in case of iterative model. That is the small scale. And all the steps are followed and the initiation is taken into consideration. That is, the planning is considered into it. Then on every next iteration, more features and modules are designed and coded, tested and added to the software. That is, if there are any changes required, we shall do it in the next iteration. Similarly, if there is any changes required, we shall do it in the next iteration. That is 1, 2, 3, 4, 5, 6. All these phases are repeated in each and every iteration. So there is no need to worry about it. Similar to the worry which we have in case of waterfall model. Then iterative model. The management team can take the risk management and prepare for the next iteration. So there is a possibility, there is a chance to take the risk management. Suppose if there is anything is missing in the present phase, we can incorporate in the next phase. So there is no need to worry about it. So the risk management is possible in case of iterative model. Because a cycle includes the small portion of old software process, it is easier to manage the development process but consumes more resources. It is very easier to incorporate but consumes more resources. That is very, very important thing you need to understand in case of iterative model. Similarly, if I move on to the third type of model, that is spiral model, you will observe that it is a combination of iterative and any one of the software development lifecycle model. Whether it may be an iterative with waterfall model, iterative with any other type of model, it is a combination of iterative with any of the types of software development lifecycle model. Whether it may be either this one. What is that? We have Big Bang model. Big Bang with iterative, waterfall with iterative or anything. That there has to be a combination of iterative with any other type of waterfall model together forms a spiral model. So if that is the case, we shall see to it. What is that? This model considers risk which often goes unnoticed by most other models. Suppose if there is any risk or if there is any mistake which you have committed in the present phase which is unnoticed, which shall be noticed in this spiral model. Why? How it is going to be noticed? Let me take you into that. This model starts with determining the objectives and constraints of the software at the start of one iteration. Next phase of prototyping begins. That is, if you look at this diagram, you will understand that objective initiation. Here you have the first part, that is the risk management, that is possible. Second one, prototype. As I have already told you that a prototype is a model which works similar to the original model, which works as if the original model is in place with the customer. That is called as a prototype model. A prototype model is delivered to the customer and the customer works with the prototype model and comes back to the developer with certain requirements which needs to be incorporated in the next phases of the software development lifecycle. So, iteration is also possible. At the same time, we have the possibility to incorporate any changes into the existing system. So that is why I am stating that it is a combination of iterative model with any of these types of models, so that the unnoticed flaws or mistakes can be noticed in any phases of this software development lifecycle model in case of spiral model. Then you will come across design, code, integration, test, then implementation, then finally release. During the next phase, you will repeat the same set of phases. So we have an iterative type of model in combination with any other type of model. That is the thing we are explaining here. Then one standard SDLC model is used to build the software. In the fourth phase, the planning of the next iteration is prepared. That is in this phase. This is the first phase, this is the second phase, this is the third phase, and this is the fourth phase. Here in the fourth phase, you can plan what shall be incorporated in the next iteration. That is possible in case of spiral model. Then we shall move on to the next type of model, that is V model. V model is also called as verification and validation model, because once you develop any software, before being delivered into the market, it shall be tested, it shall be verified and validated at the same time. That is why we call it as V model. V stands for verification and validation model. So if that is the case, let us see that requirements gathering is the first phase, which you will do normally with the customers. That is to collect the requirements of a customer. You will go through this phase. During this phase, if there is any changes needs to be incorporated, then you will test with him. You will ask what is the changes you require in this, then immediately you can come to it and do changes in this. Similarly, this is the second phase. In the second phase, you will go through the system analysis, and if there is any changes required in the analysis and design process, you can do it in this bidirectional process, that is system testing. Then similarly, moving on to the third, you shall see that there is a down arrow, that is in the software design. You shall move on to the integration testing as well. So these things can be done parallelly, simultaneously. That is the fourth model, that is model design, module design. We have a unit testing. Unit testing is done at the developer's end. So he can do the module design as well as the unit testing at the same time. Then finally we will move on to the coding. That same thing, this is done. Once it is completed, coding is completed, we will move on to the validation model. This is called as a verification model. This is called as a validation model. So we have V and V, verification and validation, both is being carried out at the same time. So we will call it as a V model. So in this case, once when the unit testing is being carried out, what is the meaning of validation? Let me tell you that a validation means whether all of the requirements given by the customers is going to be met or not. That is called as a validation. What is called verification? Verification means everything which is asked by the customer is properly incorporated or not. That is called as verification. Verification and validation. Verification means everything that is required by the client is met in this or not. Validation means the code which is developed by the developer is working according to his requirements or not. That is called as a validation. So both verification and validation is carried out simultaneously in case of V model. So, V model provides a means of testing of software at each stage in reverse manner. That is, this, when doing the implementation, module design can also be done. When doing the integration testing, software design can also be done, and again that testing can be done. So, this process is possible in case of this V model. That is, when doing the system testing, again system analysis can be done, and it can be go in this reverse direction as well as in this direction. So that is why it is called as a bidirectional model. Then again, when it comes to the acceptance testing and ready for delivery, it is once again cross-verified with the requirements gathering. So we have this bidirectional information here. So that is why we call it as the verification and validation model. V model is also called as a verification and validation model. Moving on to the next slide, here you will see that at every stage, test plans and test cases are created to verify and validate. I am using the word verify and validate. What is that verification stands for? Verification stands for whether all of the requirements are met in this or not is going to be tested. Validation, whether the requirements of a client is accurately completed or not, whether the tasks required by the customer is going to be met in this, that is called as a validation. So you shall see that there is a difference between verification and validation. Product according to the requirement of that stage. For example, in requirements gathering stage, the test team prepares all of the test cases in correspondence to the requirements. What is that required for the customer? What is that required for the client? Everything is going to be collected at that phase of requirements gathering. Then, if there is any more changes required before the delivery of that, at the initial stage itself, he will ask what is the required thing required for the customer. So that is also possible in case of this. Later, when the product is developed and ready for testing, test cases of this stage verify the software against its validity towards the requirement at this stage. Once it is verified, the validation is also carried out. That is, verification is done in this manner and validation is carried out in this manner. This makes both verification and validation go in parallel. As I have already told you, simultaneously verification and validation process can be carried out. This model is also known as verification and validation model, also called as V model. Now, let us move on to the next model, that is Big Bang model. In case of Big Bang model, we will come across the simplest model in its form. The name Big Bang indicates that it is formed after the Big Bang, the new stars and galaxies are formed. In the same manner, with the initial planning, we will start developing the product. Once when the new changes are required, we will start incorporating and doing the changes in it. But the only difficulty or the drawback with this Big Bang model is it is very expensive. Very, very expensive, because we do not know what is actually required for a customer. Initially, when he consults the software developer starts developing. At the later point of time, he may come up with new requirements, then that has to be incorporated in the existing system. That requires more cost in terms of time and resources and budget. That is the reason we are stating that the Big Bang model is very expensive in comparison with every other models which we have discussed so far. So, as scientists say that after being Big Bang, lots of galaxies, planets and stars evolved. The same thing which we have been using right now, that is the lots of programming and funds, you may achieve the best software product. Then similarly, the Big Bang model, very small amount of planning is required. That is, initially we start with a small plan. Later when the customer comes with a new changes, we can do it. Of course, there is no problem at all. But the only thing is, it is very costly, expensive in terms of time, budget and resources. That is the reason we call it as an expensive software development model, because the customer is not sure about what is required for him at the initial stage. Later, when the later part of the software development process, he approaches or consults the software developer and comes with a new problem which needs to be solved. A solution to the problem is to be given. Then it is very expensive. That is the need. Meaning requirements and future needs. So the input requirements are arbitrary. There is no specific requirement. This is an arbitrary requirement. That is about the Big Bang model. Then, thank you very much. In this session, you learnt about the different types of model. The very first model is the waterfall model. The second one is iterative model. The third one is spiral model. Fourth one is V model, and fifth one is Big Bang model. So all these are different types of models which you have come across, and you shall go through this information which we have conveyed in this present session. Thank you all.